Hello, good evening.
Good evening, sir.
Ain't out from last class? Minashi, ain't it out?
No, sir.
Okay,
So I have one doubt, sir.
just tell me.
So it was there in the assignment. So like when gas will heat up, upon sudden compression, the gas will get heat up. That one, sir.
Okay, just 1 minute. The question was, will there be any change in internal energy on sudden compression or sudden expansion without any supply or ejection of heat? That was the question?
No, sir. It was some question like proving. 1 second, sir. It was like to prove that upon sudden compression, the gas will get heat up.
Okay. So when there is a process in which there is sudden change, sudden expansion or sudden compression, just 1 minute. Okay. So sudden expansion, sudden compression termed as adiabatic process. So you'll say dq equals to du plus dw according to first law. Since dq will be 0, so du equals to minus of dw. Is it clear?
Yes, sir.
Now, during sudden compression, volume will get decreased, so work done will be negative in this case. So take the sign of this particular work done to be negative. So negative and negative will become positive. So internal energy for this case will be positive. It means temperature will increase or decrease.
Increases.
Hence, gas will heat up. Is it clear?
Yes, sir.
Any more doubt?
No, sir. Thank you, sir.
Okay. In last class, I had defined you about how to calculate efficiency of heat engine. let me give you any question related to this part. A heat engine working between 27 degrees Celsius and 127 degrees Celsius absorbs 2 kilojoule from source. Find first efficiency, second work done, and third heat ejected. Try to solve this part. Hello, am I audible?
Yes, sir.
There was some issue in electricity. That's why I got disconnected. Okay. Question was, given that is temperature of source is 1 to 7 degrees Celsius, just convert it into Kelvin by adding 273. So it will become 400 Kelvin. T2, that is temperature of sink, 27 degrees Celsius plus 273. So it will become 300 Kelvin. So using it, try to find eta, that is 1 minus T2 over T1. Second part, amount of heat absorbed by source or absorbed from source is 2 kilojoule. So 2 into 10 to the power 3 joule. So we have to calculate work done. And next is heat ejected out into sink. So you may use this particular efficiency as work done by heat absorbed. So from this part, you'll get work done, and then work done equals to Q1 minus Q2. So you'll get amount of heat ejected into sink. Try to solve. Good, Krishna. Good, Minashi. If you put the value of T2 and T1 in this expression, you will get 1 minus T2, we have 300 Kelvin by T1 400. So 0 and 0 will cancel out. So 4 minus 3, that will be 1 by 4 or simply 0.25. So this will be your efficiency of this heat engine. Next, eta equals to work done. We have to calculate by heat absorbed. So work done equals to 1 by 4 times Q1, that is 2000. So it will become 500 joule. And last, work done equals to Q1 minus Q2. So Q2 will equals to Q1 minus work done. So 2000 minus 500 equals to 1500 joule. Is it clear to all of you?
Yes, sir.
Yusra, any doubt?
Sir,
Yes,
Q1 was given in the question, right?
And T1 and T2 was given in terms of degrees Celsius. So first we have to convert into Kelvin and then use the formula for efficiency to find eta. And then later on, using these relations, you may be able to calculate these expressions. Gautam, is it clear?
Yes, sir.
Nabila, any doubt?
No doubt, sir.
Have you all done till this part?
Yes, sir.
Now, from this part, you can see about limitation of first law. It simply defines the flow of heat should be unidirectional, that is from higher temperature to lower temperature body. So you'll say first law defines the unidirectional flow of heat, that is from higher temperature body or system to lower temperature body. Just write it down to this. You all have written?
Yes, sir.
Next is second law of thermodynamics. To define this, let me give you statement of two different scientists. First is Kelvin Planck statement, and second is Clausius statement. Suppose this is any source and this is sink. There is a working tool So this working tool may absorb some amount of energy from it and convert it entire term into work done without any loss of heat into surrounding. So this is not possible. Similarly, suppose this is any higher temperature body and this is any lower temperature body. And there's a working tool in between. Let's say it absorbs energy Q from some lower temperature body and transfer it towards higher temperature body. So it will also not possible. So in first part about Kelvin and Planck statement says there is no process whose sole result is absorption of heat from source, that is from higher temperature body, and complete conversion of heat into work done or mechanical energy without any loss of energy into surrounding. It means if this could be possible, then efficiency of heat engine will become 1, that is 100%, which will not possible in practical. Is it clear?
Can you repeat?
According to this, we can say there is no process possible whose sole result is absorption of heat from source and complete conversion of this heat into mechanical energy or work done without any loss of energy into surrounding. It means Q2 for this process is 0. So efficiency of this particular engine will become 1, that is 100%, and it could not be possible. Is it clear?
Yes, sir.
So we can say from this part, no process is possible whose sole result is absorption of heat and conversion into work without any loss into surrounding. In second part, let's say this is any lower temperature body, and this is some higher temperature body. So there will be no any process whose sole result is absorption of heat from lower temperature body and transfer it completely into higher temperature body without any external agency. This would also not possible to transfer heat from lower temperature body to higher temperature body without any external agency. Is it clear?
Yes, sir.
So we can say no process is possible whose sole result is absorption of heat from lower temperature body and transfer it to higher temperature without any external agency. Just write it down to this part.
Without any external
agency. So on conclusion, we can say from these two parts, there should be some requirement of external agency to flow heat from lower temperature body to higher temperature body. Is it clear? Suppose this is any object which is placed over any surface initially at this surface. So if you have to move this particular object from lower temperature or from lower surface to higher surface against gravitational potential energy, So what you have required, some external agency to do some work, move it from lower gravitational potential energy to higher gravitational potential energy. Is it clear?
Yes, sir.
Yes, sir.
Similarly, in this part, we can say if you have to move heat from lower temperature body to higher temperature body, you must require some external agency to do work which is equals to difference of energy of these two different bodies. Gautam, is it clear?
Yes, sir.
Okay, just write it down to this. Well done.
Yes, sir. Done.
Mazia, any doubt? So on the basis of this, we may define two different terms. First is the refrigerator, and second one is heat pump. In case of refrigerator, let's say this is cabin, which is at lower temperature. This is any working tool or compressor. And this is surrounding at higher temperature water. This particular cabin is also called region of interest for this particular refrigerator. So we can call it as the region of interest. So it absorbs small amount of heat from this cabin at lower temperature to cool it down by adding work from compressor W, eject some large amount of heat into surrounding, which is initially at higher temperature. So let's say temperature of this particular is T2 and temperature of surrounding is T1. So it is transferring energy or heat from some lower temperature body to higher temperature body by applying some work from any external agency, that is compressor. Is it clear? Krishna, any doubts?
Sir, can you repeat again, sir?
In this part, let's say this is given of fridge. So we have to cool it down. So how to cool it down? By extracting heat from it. So let's say this fridge and extracted Q2 amount of heat from this cabin at lower temperature body to cool it down by adding some work from compressor. In total, these two combined together to form Q1, which becomes higher as compared to surrounding. So it can easily donated or ejected easily into surrounding at sufficiently larger temperature. So it is doing transfer of energy or heat from some lower temperature body to higher temperature body by use of external agency, that is compressor. Is it clear?
Yes, sir.
Gautam, can you have
So what is written near the blue body? The one with starting with the C.
cabin? Compartment of fridge. We can say.
Oh, okay.
So for this part, we need to find absorb heat from cabin, that is the region of interest. Cool it down by adding work of compressor it eject or donate heat to surrounding at higher temperature. So for this part, if you have to calculate its working performance, first write it down. Then I'm defining it.
Done, sir.
Raza, any doubt? Okay, similarly, heat pump, you can say. Let's say this is surrounding at low temperature. So from it absorbs equal amount of heat by adding work from compressor. It will mean Q1 larger amount of heat into room to warm it. So for this part, we can say it absorbs heat from surrounding at low temperature by adding work compressor it means large amount of heat into room to warm it. Both are doing the same thing, but their region of interest is different. In case of heat pump, the region of interest is room, but in case of fridge, region of interest was cabin or the compartment inside of fridge. Is it clear till this part?
Are there actual heat pumps
Yes, Gautam?
in practical situations? Are there real heat pumps from the surrounding?
You must have heard about Voltas AC.
What AC, sir?
Voltas all weather AC, air conditioned.
The normal AC.
Suppose normal AC what it does? In summer, it extracts heat from your room and eject it into surrounding by doing work from compressor. So to cool it down, okay?
Yes, sir.
But in winter, it must have to do opposite of it. Extract heat from surrounding by doing work of compressor, it ejects heat or sufficiently larger amount of heat in the same room to warm it. That is bi-directional work of air condition.
Okay, sir. I thought they used heating oil to heat the room.
No, I'm defining about heat pump, not the heater that works on heating element of coil by the use of electricity without any use of compressor and these type of mechanism.
Okay, sir. Got it. So the normal ACs don't have heating elements?
No, it only works unidirectional.
Okay. Wait, unidirectional means?
That is from extracting heat from cold surrounding or simply to cool it down, and by adding work of compressor to eject large amount of heat into surrounding. And the reverse process is not possible.
So normal ACs cannot work as heat pumps?
Yeah.
Okay, but there are special ACs which can work as heat pumps, right?
Centralized AC, you must have seen in mall.
Oh, yes, sir.
Have you all done till this part?
Yes, sir.
Nabila, any doubt?
No doubt, sir.
Now we have to define its working performance or simply efficiency. So in case of fridge, working performance alpha is equals to how much it has absorbed heat from cabin. So heat absorbed from cabin divided by how much energy is given to it by compressor. So work done by compressor. So heat absorbed is Q2. Work done will be Q1 minus Q2. In terms of temperature, it will be T2 divided by T1 minus T2. That is working performance of fridge. Similarly, heat pump working performance denoted by beta. How much heat is donated into room? Heat divided by work done by compressor. So it is equals to Q1 divided by Q1 minus Q2 equals to beta. In terms of temperature, it will be Q1 divided by Q1. Now, we have three different devices. First one, engine. Second one is, third one is heat. So you have to relate the efficiency or working performance of all these three. So in general, beta equals to alpha plus 1, which is equals to 1 by beta. So depending upon this relation, you'll be able to calculate the rest of the whole term by knowing just one. Gautam, is it clear?
Yes, sir. Let me write it down.
Okay.
So why are we doing Q2 by Q1 minus Q2?
In case of fridge, how much it has absorbed from this region of interest? Is it actual work done or is actual work of fridge to cool it down? And how much energy is supplied from external agency or electricity? That is work done. So its efficiency would be Q2 divided by work done. Is it clear?
Yes, sir. So T2 for the fridge was of the compartment.
Yeah, T2, that is lower temperature body.
So why we are writing 1 by n?
This is the relation between all these three terms. As we had eta equals to 1 minus T2 by T1. So if you simplify it, you'll get T1 minus T2 divided by T1, and which is nothing but just 1 by beta.
Okay, sir.
Are we all done till this part?
Yes, sir.
Now there will be one conceptual question regarding it. What will happen if you place a fridge into isolated room and kept the door open? What will happen to the temperature of a room if door of fridge is kept open? Suppose this is your room, isolated part, and a fridge. This door is kept open like this. So what will happen to the temperature of this particular room? Will it increase or decrease? Just think.
So the room is isolated, right?
Yeah.
It will become cold, sir.
Cold. Okay.
Because the refrigerator is doing work on there. Cool it down.
Just 1 minute. Anyone would just think temperature will increase? Or are you all agree with it? Temperature will decrease? Raza? Temperature will increase or decrease? Decrease. Okay. Just think, if you open this particular door, so this cabin and this entire room becomes common. So it extracts heat Q2 from same room, which is acting now act as cabin, and by adding work of compressor, it ejects larger amount of heat into same room. So on each cycle, amount of work done by compressor causes to increase the temperature of that particular room. Hence, temperature of room gradually increases. Is it clear? Let me define you again. If you open the door of this particular fridge, so this cabin and this entire room will behave as common system. Is it clear?
Yes, sir.
So it will absorb Q2 amount of heat from the surrounding that is behaving as cabin. And by adding work of compressor, it ejects some larger amount of heat that is Q1 into same surrounding, that is same room. So on each cycle, the net amount of work done by compressor will be responsible to increase the temperature of room. Hence, temperature of room gradually increases. Gautam, is it clear?
Yes, sir.
Now, the next question will be, so why we can't use fridge as heating element in winter and as a cooling agent in summer? So you will say, just look the efficiency of both these two objects. Heat pump is more efficient than a fridge. So if you use fridge as heating element, you have to pay off larger electricity bill. Is it clear?
Yes, sir.
Yes, sir.
Nabila, any doubt?
No doubt, sir.
Okay. So we can say in this part, if door of fridge is kept open. Then cabin and room will behave as common system. So it will extract or absorb Q2, lesser heat, and by adding work of compressor donate Q1 larger heat into same room. Hence, temperature gradually increases. Mazia, any doubt? Okay, just write it down. I'm just giving you 5-minute break. I'm coming back. Okay. Hello.